So S sub n, I'm not going to write the sum thing again. You guys will kill me. A sub 1 plus A sub 2 plus A sub 3 plus dot 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 plus A sub n. Now remember, this guy is arithmetic. That's key. This formula doesn't work if you're not talking about something that's arithmetic. So let's play with this. You ready? Well, there's got to be a way to figure this out. I know it's A sub 1 plus, weren't all of these terms defined by A sub 1, right? So wasn't A sub 2 just A sub 1 plus 1 times D as opposed to N, right? I'm going to put that in parentheses. And wasn't A sub 3 A sub 1 plus 2 times D? Because all I'm using here, you guys and gals, don't mean to be gender biased, is, where's my formula? Is this formula, gosh, I'm losing all my formulas, this formula right here, right? That's all I'm doing. So 2D, plus, put that in parentheses. Let's do one more. This is going to be plus, so this is A sub 2, and this is A sub 3, plus A sub 1 plus 3 times D, right? This guy's A sub 4, and then we're going to go plus, dot, 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 plus, and the A sub n is just A sub 1 plus n minus 1 times D. You with me? Remember, the whole purpose of what I'm doing right now is simply to find an equation. I want to use an equation because I don't want to be adding up a whole bunch of stuff, especially if there's like, 1,000 things to add up. So I'm just being fancy. I'm using what I know. I'm trying to come up with an equation. Well, the first thing that I happen to notice is that I'm for A1 through, this is AN by the way, is that for A1 through AN, I end up with how many A sub 1s? Well, this was when it was A1, right? 1, 2, 3, all the way up to N. I end up with, I'm adding A sub 1 to itself N times. So this is definitely going to be N times A sub 1. So that takes care of all of those, right? Now, watch this, because this can get a little crazy. This is going to be, the first term here is going to be D plus 2D plus 3D plus dot, dot, dot. Now, what's my last term going to be? It's going to be N minus 1 times D. Okay? So, this is where it can get a little bit crazy, is with this last term. I hope nobody minds this, but I'm going to write this as N times D minus D. Now, you may be tempted to cancel that D with that D, but we're not going to do that. We're going to do something a little fancier here. What I'm going to do is, well, you know what? Actually, I lied. I'm going to leave it as N minus 1. Keep it simple, because otherwise you guys are going to yell at me, and I don't like to be yelled at by my students. Look, do we agree that if I take the sum as k goes from 1 to n of k, then this is 1 plus 2 plus 3 plus 4 plus dot, dot, dot plus n. And we know from our equations out of 12.1 that this is n times n minus 1 all over 2. Do you agree with that? Now, why did I just show you that? Well, watch. If I do a little bit of algebraic tomfoolery, this guy turns into n times a1 plus d times 1 plus 2 plus 3 plus dot, dot, dot plus n minus 1. You see that? Which really, if you think about it, all that it does is it turns, I'm going to change the colors on this, it changes this into the sum. This sum right here can be written as the sum as k goes from 1 to n minus 1, right, of k, which should turn into, if all I do is turn all my n's here into n minus 1s, right? Whoa, n minus 1. You gotta yell at me with that. Sorry, you guys. I'll throw one of those funny little call-outs in. It's n times n plus 1 over 2. Yuck. Sorry. All right, so back to blue. All that this does, where if if I add from 1 to n minus 1, then wherever I see an n in this equation here, simply stick an n minus 1. What I get is n minus 1 times n minus 1 plus 1, which is just n, all over 2. You can see where that n minus 1 came from now. Right? Now, I'm going to let that soak in for just a sec. Think about that. It's not that big of a move. It's not that scary. It's the difference between summing, well, screw that. It's the difference between summing, if I go 1 plus 2 plus 3 plus ... 17. I end up with 17 times 18 tooths, right? If I go 1 plus 2 plus 3 plus ... plus 16, I end up with 16 times 17 tooths. If I go 1 plus 2 plus, think of this as being n, and this as being n minus 1, right? Then all I do, if I go 1 plus 3, is plus ... plus n minus 1, then notice what I did. I just stick in n minus 1, multiply it times n minus 1 plus 1 is just the next term, which is n all over 2. I think I've flogged that pony for now. All right, so now we have an equation. Look at this. It may not be the prettiest equation in the world, but God bless it, it's going to work. I got n times a sub 1 plus d times n minus 1 times n all over 2. Another way to write this is n, because they both have n's in them, notice that, n times a sub 1 plus d times n minus 1 over 2. So notice what you need to make this formula work. Notice what you need. I need n, I need a sub 1, and I need d, just kind of like I did before. Now, your author chooses to rewrite this guy. You can rewrite this. If I find a common denominator, this turns into n. I'm going to find a common denominator, so I end up with, what, 2a sub 1 plus nd minus d. You know what? I'm not going to do that. I'm going to leave that as d times n minus 1, because otherwise it's just silly. d times n minus 1, the whole thing over 2. And then if I factor out the 2, I end up with n halves times 2a1 plus d times n minus 1. Now, isn't that clever? That's the formula. Now, hopefully what you're seeing here is, if you look really close at this equation, what do you notice? I'm going to change colors because there's a more clever way to write this equation. And this is what mathematicians do, you guys. I know that we annoy you from time to time, especially for those of you that don't consider yourselves mathematicians. But you got to admit, it's pretty darn clever when you look at stuff. Now, look close. If I'm a mathematician, this is a cumbersome equation to work with. Right? It's just ugly to look at. There's freaking parentheses everywhere, and like even I forgot to square that thing off. So is there a more clever way to do this? Well, watch. If I go n halves, and I'm not going to see 2a1. I'm going to see 2a1 written as a1 plus a1. See what I did there? Plus d times n minus 1. And then all of a sudden, my spidey sense starts to tingle. I've seen that equation before. Where have I seen that equation before? Oh, sweet goodness. That's a sub n. A sub n is defined as a1 plus n minus 1 times d. So stumble back over here. a1 plus n minus 1 times d. Use the commutative property if you must. And this guy turns into n halves times a1 plus an. Well, look at that. Isn't that pretty? I love it. All right, cool. Hope you enjoyed that. You know what? I think I'm going to end it here. I think I'm going to let you guys kind of muddle around with that if you choose. Otherwise, we can play with it tomorrow in class. You're getting to a point, these are some pre-calculus topics, so you're getting to a point where I want you to be able to I don't know, struggle with these a little bit. Ask me for help. Use me more in a tutorial fashion than me having to show you how these bad boys work, even though these are pretty tricky. And I do definitely give you that there are going to be some struggles, and I'll be happy to help you out. So again, hope you enjoyed. I'll see you in class tomorrow. Have a great day. Bye-bye.